Okay, good Lord willing, we just got some flying footage for you. I'm going to continue with the tape. I haven't had a chance to look back and see, but we're going to go with it. You know, these are homemade videos anyway, and what we're going to do now is what I'm trying to do on all the tapes is a total weight of the airplane. Okay, I've already set the scales to 0, and I've got the airplane on the scales. We'll walk around and read them. I'm going to put my little stick here in the gas tank to show you how much gas I have, and then I'm going to roll it back and walk around and show you that they're all zeroed out. And I'm not going to stop the tape, I'm just going to kind of do this, so I hope I don't make you too dizzy. So what I'll do now is I'll go ahead and read the tapes, or the scales. This one here, I'm going to jiggle a little bit. 120 pounds. Right tire. Just under 110. We'll call it 110. And I'm going to jiggle it. Where's 110. And this one is 20. So 120 this side, 110, that's 230, 40, 50, 250 pounds as it is, but we do have gas in it. And if I can get up here, I'm going to show you that. I'll leave it under here. Yeah, there it is. See the line there? Which is, come on, stay there, line. Well, I hope you can see it. Right there where my finger is the line. So we've got a little over a half a tank. Yeah, you can see the line there, I believe. Got a little over half a tank of gas. So we'll call that 2 gallons. It's a 4-gallon tank. Just to be on the safe side, we'll call it 2 gallons, 12 pounds. So 12 minus 250, and you've got the total empty weight of this airplane. It's totally 250, just like it sits. And my buddy up there is working on his Quicksilver, and he's got the concrete pad. So what I did is I found the hardest ground that I could. You can see the scalded places here, and it's sitting right on the ground. So what I'm going to do now is I'm going to put my stick down and roll it back and off. And you see that one is zeroed. That one is 0. And that one is 0. So, the reason I'm doing this is because a lot of people question whether or not manufacturers or people who sell plans actually weigh what they say they weigh, and this is to prove that it does indeed. very lightweight. This is bare minimum ultralight, so what I'm going to do is I'm going to do my walk around, give you an idea how I've kept it lightweight, and with the weight that it is setting at, it is going to give you some leadway. You're going to be able to put a lot of different things on it. You'll notice with this weight that I'm giving you, it has brakes. It has mechanical brakes, and that is with the weight. It doesn't have any instruments, and it's got a 4-gallon tank. So this thing, just like it's setting, just like we just did, weighs 238 pounds. And then you take off, if you add a ballistic parachute, you can go up to 278 pounds. I usually fly with a chute. I didn't just a while ago when a guy was taping me, and shame on me, I should have, but I've got so many airplanes I have to switch them out and back. And I would recommend putting a chute. Where I have my chute installed is right behind this nose bowl here, right here, and I'm going to put a windshield and stuff. I'll discuss that. Let me get the scales out of the way, and then we'll start to walk around, and we'll continue from there. But that is the weighing of the airplane, the RagWing MotorBipe. Okay. RagWing MotorBipe again. Continuing with the tape. This runway here, the one I was just taking off on earlier, is about 550 feet long, but it's not all usable. That's my Ultra Peak down there and my hangar that I sell plans for. But you can see the trees, you can see coming up the hill. I'm basically sitting on the hump here, and what I was doing is I was starting right back here in front of the hangar. I was getting to the hump, which is about 150 feet, and I believe I could have rotated, but such a short field, you don't want to risk it. The hump here kind of gets you bouncy, gets you a little bit airborne, and then I try to continue down the hill a little bit and rotate. So it's about 150 feet takeoff roll with the prop and reduction that's on it, which isn't real efficient. So about 150 feet. Now I'll go ahead and talk about the engine and propeller, just because I just mentioned it, and give you a little side view of the airplane. See the little side view. Okay. This engine reduction and propeller is a Kawasaki 440A. It is taken directly off of a Phantom Ultralight, which runs a 2.0 to 1 4-belt redrive. It's not a K-drive, but it's very similar. You can see the 6-inch pulley in here and the 3-inch pulley down here gives you the 2.0. Well, the 2.0 is known not to be a very good redrive. It's what they call a wah-wah drive, because when it's going through the air at full throttle, you can hear the wah wah wah, and that's why they call it a wah wah drive. So they're not very efficient. The prop is a 58-inch 22 pitch. Use my little pointer stick here now. 58-22. This particular setup puts out about 155 to 160 pounds of thrust. It's not a very efficient redrive because the prop is so short. It would be better to go with a 2.6 that Jay Bird recommends. He's in Wisconsin. Phone number is 414-626-2611. And he sells the redrives for this. What I would recommend for this airplane is either a 2.6, 2.8, or 2.9. And that'll be in the plans. Now the redrive that I have on the Pete and the Special, well, you can't see it, but the Special has a 2.9 ratio and a 72-inch 32 pitch, and that puts out about 210 pounds of thrust, about 50 more pounds than this. And this airplane would fly much better with it, but because this came as a whole package and I bought it used off of a Phantom, that's what I'm going with. The muffler package, everything as you see it there is directly off of a Phantom ultralight. The muffler is identical to that. Everything is exactly the same. The only difference is the motor is mounted upright on a Phantom and it's inverted on this one. You can see the muffler comes straight out to a Y, and it does the little loop around, and the spring's holding on, and the muffler mounts right to the starter position. If you're going to run a starter, it would mount here and you wouldn't be able to have this bracket. I'll try to give you a view on the inside. It's not going to be very easy, but you can see the engine plate, which sets on the rails, goes forward, the rubber mounts, and the redrive on top. And this is the fiberglass nose bowl that I will be producing and selling just like I do on the Special Bipe. It's fiberglass and it's very light. I'll continue with the engine. 32mm carburetor. The gas line and ball here. And this is the support for the rails coming forward. So and there you see the engine plate that you saw on the upper side. And this is a 4-belt. These belts like this, the 4 separate belts are very, very good. I like them. I've never had a problem with them. I recommend them a lot. The K-drives are much better than these, but they're same type of pulleys. These mufflers are very good. I can sell these mufflers. I have a stock of those. If you can't get the ones like this that are round, I can sell you one. They run $100 a piece. This one, if you know much about engines, you may not recognize this little setup here. And this is an adjustable jet that you can buy, where you can adjust it in flight. And I've got that run all the way back to where I can adjust it up here in flight. And what that helps you is if you start off here and go, which is about 1,200 feet, and you go up to about 6,500 feet, it will start getting rich. So you can just reach up and lean it out and you can still continue to climb. The Kawasaki, you can use a Kawasaki 340 or 440. Both of them are very good. I recommend the 440, but you can only get them rebuilt now up to new condition, but you can't buy a brand new one unless you just happen to find one. Okay, I'll continue on back. What I'm planning on doing, like I said, this plane is in the testing phase. It's got approximately 45 hours on it now. What's going to happen is when I get ready, I'm going to put some Lexan that wraps around the airfoil here. It comes straight down. So the angle that you're going to have is about like that. And then of course it's going to wrap around this way, and it's going to wrap down to the engine mount there. So, and then what I may do is I may flip the edge up and bend it and divert some air away from me, because as it is right now you do catch a lot of air. It's going to be better with the windshield, and then it's going to even be better, I think, with this, but that's all going to be testing, and it's just going to be a wraparound thing here. I'm enjoying flying it like it is now because the weather, just like today, is about 90 degrees and it's still early morning. So the performance isn't very, very good, especially with this prop combination that we talked about. But if you can get an idea of how it would look with a windshield, it's going to look much better, I think. Say we'll do a profile, we'll keep on going back. Okay, I've got this, so it's just Velcroed on. It's 25 thousandths aluminum. And I can give you an idea about how it's connected in here. You see the straps that are connected directly to the spar, decel wing, all wood wing, and it attaches to the cabanes here. The vanes continue run all the way down to the landing gear crossbar, this U-bracket here, so it's all kind of tied in together and it's pretty easy to build. The U-bracket sticks out. We've got reinforcements here. You can see this 24 quarter-inch stick is a reinforcement for the U-channel because your flight and landing loads are going through here. Engine mount rail bolts directly to that also. The pedals, aluminum pedals, bolt directly to that, and the landing gear leg in the center bolts to that. Now I have a reinforcement just like this on the back side back here, so you can't see it. I'll try to get it when I go around to the back. But a reinforcement plate just like this 2024 here is on the back side of here, and that helps the pressure from the landing pressure when you're landing it. It's got a lot of pressure pulling down through here. It reinforces this. The brakes are mechanical, bought from Northern Hydraulics. The way those work is the cable comes up, comes around, loops around here, connected to this upright, which goes to the back cabane, and there's a little hinge here and a plate. So what you do is your foot rests up through here, your heel rests right here, so it's heel brakes. I've got in the habit where I just don't use brakes. On my two landings I did before, I didn't use brakes, and I try not to use it. The only time I use them is running on pavement to keep from taxiing into somebody. That's the only time I use them. Okay, as you see, the rear cabane goes all the way up. Well, attaches to the rear spar. There's the mixture control that I talked about, and there's my little throttle lever. Get on this side, see if it's going to be any clearer. Okay, as you're getting a look at this, it's going to help if you're going to build, because you're taking a look and it's, seeing something is a whole lot better than looking at a drawing. This here is U-channel also. These 60, 61, 3/4 tubes run directly up into there, and they attach at the bottom with U-channel. U-channel's there. The strut is different from the RagWing Special, and I did the RagWing Special with wires only because of replication purposes, trying to look like a Pitts biplane. But for this I wanted to try it, just something that's going to be easy to rig. The the outboard strut attach bracket runs straight down, and like I said, all this is in the plan, so once you see it and you look at the video, it's going to kind of explain itself. These are the lightest style of struts that you can make. 6061's got a bend here, runs directly into the fitting, comes down. The 2024 wraps around, uses structural rivets to rivet it. This one is a straight tube, runs right up to the rear spar attachment. Brackets coming straight out of the wing for the eye strut or end struts, and then this one once again connects and makes a bend and goes straight into the rear brackets. This eye strut doesn't probably weigh a pound and a quarter total. It's very, very light. And as you see, the spar is directly in line with the landing gear, and the rear spar is directly in line with the front spar. Rear spar, top wing, front spar, bottom wing. So it just goes straight from bracket to bracket. And then you make this little bend here to go into the rear. So not only do you have the strut that you're relying on, The strut carries the flight loads through this and also carries the flight loads for the rear spar, but you've also got this wire carrying the loads. So you actually got two. If this wire were to fail, you'd be okay because of the strut. If the strut were to fail, you'd be okay because of the wire. They would both have to fail in order for the wing to fail. So that's a very strong arrangement. You can see the landing gear wires come from the front cabane down the front spar, bottom wing. And then you've got a kind of a landing wire, drag wire that comes from your seat attachment here down to the front spar. So you got two landing wires, one flying wire, one flying strut on each side. Very, very strong. Give you a shot of the cabanes here real quick. Now these just come up and go into U-channels and attaches to the aluminum plate. Now there's two pieces of aluminum, and like I said, all this is in the plans. Just kind of helps to see it. Okay. Two braces coming down for the seat. Now if you're going to be a heavier pilot and you don't want to be inclined as much, and you can tell from the video whether or not you probably want to be laying back as far as I am now. I'm laying back so much I'm about to go to sleep when I'm going across country. And also for heavier pilots who need to sit more forward because of getting the CG aft, what you would do is this top tube here, you would run up, let it go right through here, and then make a bend here, and then go down to the connect point right here. So what would happen is, instead of your seat leaning back like that, you put it forward, you can have your seat leaning more forward. That would be okay for lighter pilots too who just don't want to lean that far back. Okay, I need to say something real quick about the fuselage that I built. So far, this fuselage has been absolutely fine. It has been completely bolted together. No riveting except for like the eye struts, or excuse me, the end struts that we talked about. Little rivets here and there, but basically bolt together, no welding. But what I'm going to recommend in the plans is not to use all the U brackets or U-channel like this, 4 brackets, and putting an AN3 bolt or a 3/16 hole through the aluminum. What I'm going to recommend is assembly like a Warren truss with 25 thousandths aluminum plate, which is used right here on the end struts. That type of construction there to put their joints in here. See, what you have on mine is a U-bracket with a 1/2 inch going into it and a bolt through it holding the diagonal down. So you've got a bolt going through here and a bolt going through here, and I'm concerned about the 3/16 hole through this for longevity reasons. If you do the normal construction like this, the gusset and the rivets here, there'll be a gusset plate wrapped around here, riveted 2 rivets into this member, 2 rivets into this member, about 4 rivets up here, and these diagonals butt in. So when it comes around here like this, it would be riveted, couple here, couple here, couple here, over the top, couple here, this diagonal member, couple here. So it's like gusset, it's like plywood gusset, it's up here just using aluminum. And that's what I'm going to recommend for this fuselage here. And also this would run up through, there would be a hole to go through here. It would make the bend and go down if you need to do that. Which is also constructed like the tail. When you look at the tail drawings, you'll notice that the little aluminum gusset and then the 2 rivets, which this is covered and it's got a piece of tape under it, but that's the type of construction. The tail construction is the type of construction I'm talking about for the rest of the fuselage that I'm going to recommend, which is just like building a Newport 11, that type of construction, except for the wood wings. And of course the wood wings are explained in the plans. Okay, let's see. how it's going to be any better. And notice right here, some of my test flying, I had some tape to close this gap seal, and the tape does help quite a bit. It helps you get your tail up faster, and it helps you when you're flaring, because you do have quite a big gap, about an inch and an eighth in there. So what I'm going to have to do is find some tape that's wide enough. This wasn't hardly wide enough, and it came off in flight. Same way back here, I would close this gap up. It helps a whole lot to do that. These are 4130 steel hinges. These saddles here are bought from Wicks or Leading Edge. These are all in the plans. These tangs are bought from Wicks, Leading Edge. I sell the casters, the tail wheel assemblies. These here. I just want to give you a look at how it's together. You can see mine's all bolted together once again, and what I'm going to recommend is gussets here. Gussets. You can see the saddle once again for the attachment. That makes it being able to attach it to a round tube. And I've got some adjustment here. I left mine just a little bit long so I can play with my adjustment. I've got it about like I want it now. Same way on the opposite side. Here. Okay. This up here was done just for safety. Most people or companies, what they do is they're going to tell you to bend a piece of flat bar straight across and straight down. They only use one side. Here they don't have two sides. This is cut from 2-inch by 4-inch rectangle tubing. So it's almost like having two brackets compared to what other companies are doing. You can put your holes there for your adjustments. A better way to do this than to put a bolt straight through there and straight through this, which is very lightweight. A better way to do that would be to slide a 3/4 inch rod or a 5/8 inch rod into this, tap it for a rod end bearing, and then let the rod end bearing go through the bolt itself, and that's going to give you some swivel of the tube, which I don't have much of. This is just done for very lightweight, and a lot of companies do it, but a better way to do that would be a rod end bearing. Tangs, said from, you can build them yourself according to the plans, or you can buy them from Wicks or Leading Edge. As you're looking at this, you know, very simple, nothing real fancy. It's all pretty standard stuff. What I did back here, in order to make my steering for my rudder and my tail wheel, is I just come right off of I ran the wire directly to the rudder first and then spliced it to the tail wheel. Now I leave mine just a little bit slack, and that keeps it from being so sensitive. You can put springs in here, do a lot of different things, but instead of running two wires all the way up, I spliced it into here. Once again, you see the bolt construction, which I did. I'm going to recommend the Newport style of construction. I shouldn't say Newport style of construction because I'm sure they didn't invent it, but it's the Warren Truss 25 thousandths aluminum wrap with structural rivets type of construction. Most popular right now is the Newport that's built like that. Okay, this bearing material here and here can be plywood, which what this is, or it can be phenolic block, which is the best. Folded there, it works as a sleeve for the stick. See the stick coming up directly into there. The stick comes down, has the brackets, has a push rod on the bottom. Pushes it here. This is the 3/4 inch 058 6061 push rod for the elevator. And you've got some adjustment here. You do it for up and down, how much travel you want up. you want about 30 to 35 degrees up and 10 to 15 degrees down. See that there. This is also, it attaches with a little saddle that you attach to a tube. This angle here attaches to the torque tube, runs out, uses the rod end bearings that we're talking about here for connecting to the aileron. See right over there, there's the turnbuckle. For the aileron. See, it just misses where it attaches to the root there. You can see that very clearly. This is a little bracket here that I had when the wings were on the RagWing Special, so it's not necessary on this airplane. These wings are interchangeable with the RagWing Special. And you can see the seat, all I did was go to Walmart, buy some of this nylon lacing, weaved it in and out, and then use structural rivets to attach it. Very simple, very lightweight. You can see how much travel we've got up. That's about, I'm guessing 4 or 5 inches up, and you probably got 3 inches down. So you've got a little bit of differential, but not too much. But normal flight, you don't use much more than that right there. That right there. Fore and aft stick. I wanted to talk about where I put my seat. It's a 3-point system. It wraps around your shoulder like when you're getting in your truck. And it does run back. You don't want to come straight down and attach it to here. You're going to hurt yourself if you ever have an accident. And what you want to do is you want to attach it more towards the F. I've just got it looped around with a cable and a nickel press there. When I get in this thing, what I do is I come directly up, and I'll try to do it. Put my foot over, right into the seat. Drop my stick. Bring my other foot around. Now I'm sitting on the back of the seat here. Sitting right on the back. I'll try to not to bust my camera, but I slide right down. You can grab onto this, and then you're sitting in the airplane. And struts, you see the visibility is going to be really good forward. Landing, you can see your wheels. You're in level flight. To see up, all you got to do is lean back. You can see almost out the wing. The wings aren't really all that much in the way. Of course, that visibility, you've got everything. You see completely. You see the visibility is really good. You've got the strut and the flying wire, the landing wire, and the combination drag and landing wire here. And we're sitting in a 3-point position here. But you can see it's not going to be hard to see over the nose or around the nose when you're taking off. And of course you're kind of hanging out. A lot of times I'll just kick back like this when I'm flying, and when it's straight and level and calm you can do that. Stick fore and aft. Aileron travel, there's not much travel left to right, and you hardly ever use more than that right there. You're banking really steep if you're using more than that. Fore and aft, there's a little more stick travel. It makes it less sensitive. The gas tank, what I'd like to do is put a sight tube up here, which would be very easily. I can sell these tanks also, and I will. And all you'd have to do is put a fitting like I did in the pickup on the bottom, put one here and one on the bottom again, and then you'd have a sight tube. Right now I don't have any way of telling except for just timing. And you've always got a good view of your engine Everything's up front. Throttle position is optional. Of course, you're going to personalize it to how you like it. They're cut out here. Okay, I'm going to stop the camera so I can get out. Well, maybe not. I'm having to get out with one hand. Basically, I'm bringing my foot from here right up to my seat. And my seat again. Swinging right around and right out. That wasn't too bad. Okay, I'm going to cut the tape off for a minute now, see if there's anything that I haven't covered that I wanted to. See if I can remember. But like I say, it's a pretty simple airplane. I think I've covered much of everything, and I'll be right back. Okay, I guess all I forgot was the gas pickup for the tank. And I'm hoping you can see the little elbow there. And the angle that the tank sits in. And there you might be able to see that reinforcement strap I talked about, and the brakes, and the fine wire attachment there. You can tell this is U-channel. My springs for my pedal are attached to here. I've got little cable straps supporting the wire, keeping it from fluttering. I've also got a cable strap right here between these two, because this one kind of wants to go back because it is going aft. And what I did to keep those wires pulling straight is I put that around there. Cable strap. And I do believe that's going to be about it. You can see the dihedral is in the bottom wing. It's 3 degrees. Top wing is perfectly straight and it has no sweep. You can see that very well there. When I go around to the side view, I'll give you an angle of incidence. See the rounded tips. Okay, angle of incidence. Flat place on this fuselage is the bottom, which is built directly on a table. So the bottom tube is perfectly straight. This wing is perfectly straight with that, which is perfectly straight with this. Okay? So the bottom wing has 0. It's level with the fuselage. The top wing, when you build the cabines, mostly this rear tube back here, you're going to set the wing so it sets back at 3 degrees. The best way to do that is with a smart level, because all you have to do is set it up on the wing long ways. When it reaches 3 degrees, you're set. The tail is set at 0, but you can adjust the leading edge to where if you're flying a little bit nose high or a little bit nose down. I'm going to have to adjust mine a little bit now because I think I'm flying just a little bit nose high. But I can adjust that by putting washers underneath the tail connection, which I didn't go over. You see the angle brackets here, and that's how you attach the tail. You can see I've got about 2 washers under there now, and that's how the tail is attached, because this is going through here. You can see the gusset plate again. That's how the fuselage needs to be built. It's like this type of construction with the rivets. In the tail, there's one member you can see there going this way, and there's one member in the middle this way. Now all three, this side and that side, are identical. The back pieces are identical. If you were to imagine taking this right here and standing it straight up, it would be identical with this. So when you bend the tail feathers, you set up one jig and you build all three the same. This one, and this one. It's 1/2 inch 058 6061 trailing edge back here, but you build them all the same. It makes it easy. You don't have to set up a lot of jigs. And the tail spring is bungee. You notice it's got a pivot point there, and you've got bungee wrapped around up here. So you've actually got, let me try to sit on it. You've actually got a bungee tail spring, which works very good. See the bungee wrapped around there. Oops. That works extremely well. Keeps you from busting your tail springs off if you don't land just right. But that's going to be it. Do hope you like it. Got any questions, feel free to contact me, and hopefully everything will go as good for you as it has for me. I'm extremely pleased with it. It's a lot of fun to fly. That open air feeling, a whole lot of fun. Okay, thanks for listening.